Everyone, we are now on to our fifth unit and we're going to take a look at measurement. So we're going to talk about metric measurement, imperial measurement. We're also going to talk about perimeter area, surface area, volume in both types of measurement. So before we get there, we want to talk about our fraction review. And the reason we want to work with fractions, or that we're going to work with fractions, is that in imperial, parts of feet, inches, any of those measurements are taken with fractions or using fractions. So sometimes we're going to have to add, subtract, multiply fractions. We're going to review how we do that. So first of all, taking a look at how we reduce fractions. So if we have 6/8, we want to take a look at what is that in lowest terms. Well, we take a look at top and bottom and see what we can divide both by. It has to be the same number. So in our first case, 6/8, we notice that 6 and 8 can both be divided by 2, so we can reduce our fraction to 3/4. There are no common factors left in 3 and 4, so we know that it's in reduced form. For 18/54, we've got some fairly bigger numbers here. So we may have to do it in increments. If we don't notice right away that 18 can be divided by 18 and 54 can also be divided by 18, then we can take a look at, well, we know 18 can be divided by 3 or 6, 54 can as well. So let's take a look. 18 divided by 6 is going to give us 3. 54 divided by 6 gives us 9. Well, now we take a look at our 3 and our 9. We can still divide both of those numbers by a common factor of 3. So we can further reduce this to 1/3. Okay, so we're not always going to see our greatest common factor right away. We may have to do a couple of steps. Number 2, we're going to convert to a decimal. Remember, when we write in fraction form, it simply means dividing. So 5/8 means 5 divided by 8, which is exactly what we're going to do in our calculators. And 5 divided by 8 gives us 0.625. For something like -2 3/5, we can write it as an improper fraction. Remember, to write it as an improper fraction, we're going to multiply our denominator by our whole number. What we get 10. 2 times 5 means 10 pieces, plus the extra 3 on top. So we can't forget the negative out front. The entire number is a negative. And now we can put this number in our calculator. So -13 divided by 5, and that gives us -2.6. Now notice that that whole number in front is still the same as it was in the fraction form. So we could right away just leave that as our whole number out front and then put into our calculator 3 divided by 5, which gives us 0.6. Now, taking a look at our operations using fractions. So when we are multiplying fractions, we know that we're going to multiply our numerators, or our tops, and we're going to multiply our denominators, or our bottoms. Well, what we want to do first of all, though, is see, are there any common factors? Just like when we're reducing fractions to lowest terms, we can simplify a number on the top with a number on the bottom, which simply means that we're reducing those numbers. So for example, in our first question here, we notice that 4 and 8 both divide by 4. So we're going to simplify. 4 divided by 4 is 1. 8 divided by 4 is 2. So we've just reduced. And we can only do that with multiplying, and only one with the top and one with the bottom. So now we take a look at, there are no common factors with 3 and 11, so nothing to simplify there. So we're going to multiply our numerators. 3 times 2 is 6. And our denominators, 1 times 11 is just 11. Now we still want to double check, is there anything that we can reduce by? And in this case, 11 only divides by 11, so there's nothing that we can divide both of those numbers by. In part B, this time we have a dividing question. We can't divide fractions. We can't divide across the top and the bottom because we could have a fraction within a fraction, which we don't want. What we want to remember that if we are multiplying by a half, it's the same thing as dividing by 2, the reciprocal. And that's exactly what the process here for changing this to a multiplication question is: copy the first number, flip it to multiplying, and flip the second fraction. So copy, flip, flip, or keep, change, change, changes this to a multiplying question. Now we can take a look at exactly what we did the last question. 5 and 10 both divide by 5. 4 and 7 don't simplify. Now notice that when we multiply our numerators, we get -8. When we multiply the denominators, we get -7. We still need to simplify that because we know that a negative divided by a negative gives us a positive, so we have a positive fraction here. And we could also write this as a mixed fraction, 1 and 1/7. So we could create one whole thing with an extra 7th left over. For part C, anytime we're adding or subtracting fractions, we need to have like pieces or the same size pieces, which is why we have to have a common denominator. So for part C, looking at 6 and 4, we know that we can multiply 6 by 2 to get 12, which is exactly what we're going to do, and we can multiply 4 by 3 also to get 12. Well, whatever we do to the bottom of our fraction, we also do to the top. We're splitting all those pieces into parts. So the first fraction, we're going to multiply top and bottom by 2, which is going to give us -10 over 12. We also notice that when we have a subtract a negative fraction, we can simplify that into a plus. And that gets rid of both of our minus and our negative, changes it to adding. At the same time, we're going to multiply top and bottom by 3. So we're going to actually add 9/12 here. When we get the same size pieces, those size pieces don't change. We just have more or less of them. So -10 plus 9 leaves us with -1. So our final answer here is -1 over 12. Now, also taking a look at a review of metric measurement. So you can see our conversions here, and these are conversions that we are going to use the most. So we're looking at the fact that 1 centimeter is equal to 10 millimeters, 1 meter equals 100 centimeters, etc. So given these conversions, we're going to convert some numbers here. So we have 650 milliliters, and we want to change it to liters. And I'm going to show you a way that is going to work with any of our conversions. These ones are pretty simple because we're just multiplying or dividing by combinations of 10, 100, 1,000, etc. But if we start by writing down our conversion, so we know that 1 liter is equal to 1,000 milliliters, given to us in our chart here. Well, now we're going to line up what we know. We have 650 milliliters, so we're going to set up some ratios here. And what we need to know is what that is in liters. And now we're just going to cross multiply and simplify. So 650 times 1, and now we're going to kind of ignore our units right now. 650 times 1 means we have 650, and 1,000 times x is just 1,000x. Well, now what we want to do is divide both sides by 650, or sorry, by 1,000 here. to figure out what 1x is. So both sides get divided by 1,000, which means that x is going to be equal to 0.65. And that means that anytime we're using a variable, we want to state what that means if we have units, is that 650 milliliters is equal to 0.65 liters. Okay, and again, I know these are a little simpler. Once we get into more complex conversions, setting it up this way will make it a whole lot easier. Part B, we have 2.5 grams and we want to go to milligrams. Now notice that we have a bigger unit going to a smaller unit, so we should come out with more of them. So we want to keep that in mind when we're doing our calculations as well. So we know that 1 gram from our conversions is equal to 1,000 milligrams. And again, lining up what we know. We know that we have 2.5 grams, and we want to know what it is in milligrams. Again, doing our cross multiplication, 1 times x is just x. 2.5 times 1,000 is 25,000. Or sorry, 2,500, 2,500. Again, we don't have, this is just 1x, so this gives us our answer, and we're just going to state then that 2.5 grams is equal to 2,500 milligrams. Taking a look 20 centimeters into meters. So we're going to a bigger measurement, so we should have less of them. So again, starting with the fact that we know that 100 centimeters is equal to 1 meter. We have 20 centimeters, and we want to know how many meters. Cross multiplying, 100x equals 20, and x is going to be equal to 20 divided by 100, or 0.2. So again, just quickly stating, therefore 20 centimeters is equal to 0.2 meters. Okay, so some questions for you to practice on your worksheet for today. Again, any questions, please let me know.